The ICEVI, the Nippon Foundation Mathematics Package for Teachers. Title of the video: Prime Numbers. Prime Numbers. First we have to define a prime number. In any number, there are two definite divisors. One is the number itself and the other divisor is 1. So let us take the number 5. Now 1 serves as a divisor and 5 serves as another divisor. That means 5 by 1 is 5 and then 5 by 5 is 1. Okay, so there are two divisors, the number itself and the other divisor is 1. Right, now let us see how many numbers are prime numbers starting from 1. So let us take 1. Right, now can we call 1 as a prime number? Well, there should be two divisors. So 1 has one divisor, so it is dividing by itself, but it doesn't have two divisors. So that is why we don't include 1 in the category of prime numbers. Now let us take 2. Is it a prime number? We have to apply the definition. Well, how many divisors are there? Well, 1 and the number itself. So that means, if we take 2, well, 1 is a divisor and 2 is a divisor. That means, there should not be any kind of remainder. So 2 is a prime number. Now let us take 3. Can we say 3 a prime number? Well, we have to apply the definition. Can 2 serve as a divisor for 3? Well, when you take 2, then you get a remainder 1. That means 2 is not a divisor. If 2 is a divisor, then the remainder should be 0. So that means 3 is a prime number. Let us take the number 4. Is it a prime number? Let us take 4 magnets. Then what is the definition of prime number? There should be two divisors only. One is the number itself and another is 1. If there is any other divisor, we can't call that as a prime number. So let us see whether 2 is a divisor. So that means now you take 2 at a time, there is no remainder. So that means 2 is acting as a divisor for number 4. That means the number of divisors for 4 are 1, 2 and 4. So that means the number has 3 divisors. So that means the number 4 is not a prime number. Right? Now let us take 5. Let us take 5. 1, 2, 3, 4, 5. Is 5 a prime number? Now let us start with the 2 and test whether it is a divisor. So you take 2, 2 and then there is one remainder. So 2 is not a divisor of 5. Now is 3 a divisor of 5? Take 3 at a time, then you get 2 as the remainder. So 4, no, you take 4 and then 1 is a remainder. That means for number 5, the two divisors are only 5 and number 1. So that means 5 is a prime number. Now let us take 6. And when you try to find out the divisors, you have to start with number 2. So 2 taken one time, 2 times and 3 times. There is no remainder. That means 2 is also working as a divisor. So this itself is enough to say that 6 is not a prime number. However, if you want to test 3, 3 is also acting as a divisor for number 6. That means 6 is not a prime number. So 6 is not a prime number. Now let us take 7. Right. 7, in the case of 7, we have to apply the same rule, right? 1 is a divisor, 7 is a divisor. Now we have to find out whether any other divisor is there other than 1 and 7. 2, 2, 2 are taken away, and then we get 1 as a remainder. So 2 is not a divisor of 7. Let us take 3 at a time. So you get 1 as a remainder. So 3 is not a divisor. So 4 is not a divisor. 5 is not. 6 is not. So 7 is a prime number. Now the next number is 8. Now 8, you can group them in terms of 2 and there is no remainder. So what we do, take 8 number, 2, 2, 2, 2. So that means you don't get a remainder. That means 8 is not a prime number. Now the very important stage in finding out the prime number for an odd number. Let us take the next number 9. So far the child gets an impression when we go with this concept of prime number. Now except the number 2, 3, 5 and 7, the child may get an impression that, oh, all odd numbers are prime numbers. Well, this is the tricky situation. Now you take the number 9. 9 is also an odd number. Now you have to find out whether 9 is divisible by any number other than 1 and 9. Now if we take 2, 2, 2, 2, 2, 1 is a remainder. So that means no, 2 is not a divisor of 9. Now let us take 3. That means no, take 3 at a time. 3, 3, 3. Okay. So that means the 9 has the third divisor, which is 3 in addition to 1 and 9. That means 9 is not a prime number. 9 is not a prime number. So first time we are getting an odd number which is not a prime number. Now even numbers except 2, for example you take 10. 10 is an even number. In addition to 1 and 10, you have 2 serving as a divisor, 5 serving as a divisor. So the even numbers except 2 are not prime numbers. But we cannot say that all odd numbers are prime numbers. For example, take 15. In 15, 15 is an odd number. But for 15, in addition to 1 and 15, 5 is a divisor and 3 is a divisor. So that is why the child must be given practice to identify what is a prime number and what is not using these kind of examples.